Let's do it. Let's do number 2, our second area under the curve, the weird shit. Okay, so that's what we did last time. Looks kind of like what we could do by breaking it up into some rectangles with our left hand sum, our right hand sum. And just to say that we broke these into 4 different pieces, right? Just again. So we say that n would be equal to 4. And what we call this on the left, since we're coming from our left point on all of them, not from the right point, we call this L4. And we took the left-hand side and broke it up into 4 pieces. Similarly, over here, we broke it into 4. We call it R sub 4. Just a reminder as we move on, because we're going to start talking about some technical stuff. And here it is. Here's all your technical little crap that's going to be necessary. So we have some sort of curve. I don't know what the heck it is. It's just some sort of curve. We want to find the area from some point in the things. We want to find it from some point A to some point B. And we want to break it in to n pieces. Right, before E, except that. N pieces, right? Maybe that's 7 pieces. Maybe it's 4 pieces. But for this one, it's more than 4. It's just some number. We've got to get used to the concept of n things, with n just being some sort of number. Okay, so we broke it into n of these pieces. And we try to do this where we break it in, they're all equally spaced. All these are equally spaced out. It'll make life a lot easier. They don't have to be equally spaced. But it's nice if we just kind of made the equally spaced pieces, so then we can find out, like, I don't know, what's the base? What's the x value in between it? So let's see. Do you remember how to find an average? We broke it into n pieces. We could say that the value of our x, the change in, and let's call it that each one of these, let's call it change in x. This little triangle of x. That's this length right here. Well, actually to the line. This like triangle x. Triangle means change in x. We'll get more to it. So they're all into our change in x. We want to solve for what's that freaking length. And our change in x is going to be equal to, well, if you were 1 mile up to 4 miles, what you need to know how long it is first, and then you're going to divide it into that many pieces. So you do 4 minus 1 to find out it was 3 feet long or something. But we're going to do b minus a, not numbers. And then we're going to divide it by the amount of pieces we want to break it into. And this right here is big. This right here is telling us our width. The width of those little rectangles we're about to make. Shit, we're going to be estimating this stuff. Maybe some left hands, huh? Doing a little something like this. Maybe we'll be estimating with some left hands. And we might need to know how to find the area of rectangles and shit. And if you don't know the base, you're not going to find the area of the rectangle. Not right. Whatever. So we got our change in x's. Now, here it comes. I'm going to take away this and this and get all the other crap out of here so we can just focus in on one little piece. This is some technical stuff. It's funky. It's freaking weird. So we need to talk about the ith. The ith. And the ith minus 1. Good shit, huh? We're talking about the ith x, where n was just a number. Well, I is just some number, some index, some number in between 1 and n. All right. Now let's say we have this, some point right here. Whatever that might be. We're going to call this x sub 1 star. What we call a particular. No, actually, no. Let's call it a sample point. Let's just call it the sample point. That's sample point. That's not negative. Take that off there. It's a sample point. We use a little star just to say it's somewhere in between 0 and 1. It's to the left of 1. Let me show you another sample point. Let's put one right in here. And we're going to say, since it's in between 2 and 3, we're going to go to 3. We'll call it x star sub 3. Wow, called sample points. Don't stress. You don't have to do shit with them. You just have to be okay with it. Like, All right, the frickin' formula has a star in it. Yeah, get over it. Just get over it. Whatever. It's part of the piece. Just know it's some sort of sample, just some sort of point in between 0 and 1. Well, I mean our x sub 0 over here and our x sub n. But we'll get into all that bullshit a little bit later. So, ooh, technical stuff. Just little nonsense. So let's move down to our next slide. Now, I talked about it. We have this curve. Well, maybe we can go through and we can do an estimation. So there it is, and this one's actually your right hand estimate, and we have a formula for it. We have a formula for how we can actually find all of our areas, and I know it probably looks again like hieroglyphs down here. Just a lot of stuff being talked about, but I don't think it's that big of a deal. So let's go into our. Once you know it, we are adding fricking the area of a rectangle. So let's start off and let's zoom in a little bit. Now remember that the width is this change in x, from here to here. And now let's just look at our first rectangle we want to find the area of. Because they're all changing x, changing x, changing x, changing x. That's the width of all of them. Just this little symbol thingy. Okay. Now if we're going from the right, that means in our first rectangle, it comes from where it touches on the right, not from the left. Where it touches from the right, from the right, from the right, and it starts over here. Okay. So what's the height of this bad boy? And this is, oops, I don't have it written in here. Y is equal to f of x. What's the height? Well, it's just the functional value plugged in with whatever the heck's down there. It's f of x sub 1. So the height of this rectangle, we pull it aside, we're like, okay, well, we have this change in x is down below, and then we got this other frickin' symbol thingy right here. But that represents some sort of number. You'll see it when you practice. You'll actually have a numeric value. So we're going to say the area of this thing is just the change in x times the change in x times f of x sub 1. The change in x times f of x sub 1. And then we play that game just going all the way down, and then all of them are going to have a change in x. Like we go to the second one. There it is. There's your width, change in x. Your height comes right from that x sub 2. So it'll be f of x sub 2. And we move all the way down and we have an estimate. Goes down and we use our final one here at the end. And we call this b. This is the x sub n. That's the last frickin' one. The nth. Our a is x sub 0. Cool. Well, we have it. We worked all the way up. We used all of our right-hand ones. The only value of x we didn't plug in is the far left one. No, there's a right-hand estimate. And then we're also going to have the same sort of thing for a left hand. And we'll show you a little bit more on that in a second. Some L sub n, the left hand. Well, now we're going to take the far left one, right? They're all going to start like up here now. No, we're actually going to take f of x sub 0, change in x, plus f of x sub 1, change in x, plus dot dot dot, plus f of x sub what times our change in x? Well, if we're using a left hand, we're never going to end up using this height here. We're just not. That's all the way to the right. So when we make our final rectangle, we're going to be moving off from the left. And it's going to be this rectangle here. But we're using the height from f of x sub n minus 1. So we don't use the far right one. We don't use the one that's far right. I'm not talking politics either. Not far left, far right. I don't give a shit about any of that crap. But the one on the right uses all the values of x on the right-hand side. The one on the left is going to use all the values on the left-hand side, but not up to the far right one. So there are the two little estimations, and we'll play around and use them in the next. If you caught about 10% of it, hallelujah, I think you're doing freaking tremendous. This is rough. Just we need to get to the next one. Can you find the area of rectangles and add that shit up? That's all we need for next. Bye.